Hello, and welcome to your first video for Math 101 this summer. What I'm going to ask you to do, there's an assignment at the end, but to make sure that you watch these videos, I need to see pictures of the notes that you do from the videos sent to my email as soon as you watch them. So I would recommend getting out a piece of paper because today we got some notes. So let me try to share my screen with you here. So get a blank piece of paper out. You can pause the video if you need to grab one real quick. But we're going to do some notes on fractions in this first video. So once you have your paper out, you can label this day 1. And this is operations with fractions. Okay, now we'll go over some more specifics about the course in our first Zoom meeting, but for this one, I know everyone's kind of coming in with a lot of different backgrounds. So fractions is something that you've obviously all seen before, but in the however many years I've taught this class, fractions seems to be the topic that bugs people the most and still gives people trouble. So some of this is going to seem super obvious to you, and that's fine. If it is, great. And if not, use it as a refresher for stuff that we're going to need later in the summer. So first off, fractions. So fractions take the form a over b. And remember what the top number of a fraction is called? It's the numerator. And that'd make the bottom number the denominator. And there's one thing the denominator can't be. The numerator can be any number in the world. But what one number would make the bottom undefined? 0. You can't divide by 0. So the denominator can't equal 0. Okay, so we're going to do all the different operations with them. We're going to start with multiplying because that has the least amount of rules to worry about. Okay, so first off, when you're multiplying, all you have to do is multiply across. So you multiply the numerators, you multiply the denominators. Okay, so we'll do a couple quick examples and then we'll get into division. So first off, if I have 4/5 times 1/2. When I say multiply across, don't get that confused with cross multiplying. Some people think 4 times 2, 1 times 5, that's something totally different. Multiply across literally just means 4 times 1 across the top is 4, and 5 times 2 across the bottom is 10. So you get 4 over 10, but you also want to reduce to lowest terms. And what that means is if there's something that can go into both of those numbers, you take that into consideration. In this case, what goes into both 4 and 10? 2. So if I divide the top by 2, divide the bottom by 2, we end up with 2/5, and that's our answer. Okay, so again, this last step, remember when we're multiplying fractions, I'm always going to say reduce to lowest terms. Okay, let's do another one. Let's say we did 2/7 times -5/3. Okay, so again, just like before, we're going to multiply across the top, multiply across the bottom. 2 times -5 is -10. 7 times 3 is 21. And they don't reduce at all, so that's the final answer. There's no number that divides evenly into both 10 and 21. Right, next one. we've got 4/9 times 2. So when I'm multiplying by a whole number by 2, what do you know? You know that it's really 2 over 1, right? So this is really 4/9 times 2 over 1, which is 8/9. And again, there's no number that goes evenly into both of those. So 8/9 is our answer. Now, some of you might have remembered another way to simplify. So I'm just going to write, before we move on to division, note. You can also simplify before you multiply. And let me give you an example of that. Let's say I had 4/7 times 1/8. I'm going to do this one 2 ways, so I'm going to write it out twice. 4/7 times 1/8. So if we do it how I've been telling you to do so far, you would multiply across, and you can definitely do that. 4 times 1 is 4. 7 times 8 is 56. The problem is sometimes when you're reducing, when the numbers are getting bigger, it's a little bit harder to tell what goes into both. And it turns out 4 actually does go into 56. If you divide both of these by 4, you get that this reduces to 1/14. Sometimes people prefer to reduce earlier just because it makes this final step a little bit easier to do in your head. So for example, if you see a number on top and a number on the bottom of a multiplication problem that can both be divisible by the same number, like 4 and 8, I can divide this by 2. Actually, I can divide this by 4 and get 1. I can divide this by 4 and get 2. And now everything left doesn't have any common factors involved. So now I multiply across. 1 times 1 is 1. 7 times 2 is 14. And you see you get the same answer right away. So if you've seen that trick, I'm sure you've seen it at some point in your life, but if you want to reduce early, you're allowed to do that. Again, it's always got to be a number on top and a number on the bottom. Okay? Okay. All right, let's move over to dividing then. So dividing is almost the same as multiplying with one additional step at the beginning. So when you divide, the first step, you keep the first fraction. Second step, instead of dividing, we're going to multiply. So change division to multiply. And then the final step, and remember what you do to the second fraction? Yeah, you flip it. So flip second fraction. And usually when I teach this the first time, I call this keep, change, flip. So basically a division problem is the same as a multiplication problem. Let's start with an example. I'll kind of give you a visual for it also. 4 divided by 1/2. Okay, so 4 divided by 1/2 literally means how many times does 4 go in to 1/2? Sorry, how many times does 1/2 to the backwards? How many times does 1/2 go into 4? If you think of a number line, here's 0, 1, 2, 3, 4. I want to know how many 1/2s fit in there. How do I divide up 4? If I divide up 4 by 1/2, how many different pieces do I have? Well, I have 1, 2, 3, 4. There was the 4, and they all got split into halves. So 1, 2, 3, 4, 5, 6, 7, 8. And that is the answer. So if I do this, using my rules, I keep the first one, 4. I change division to multiplication. I flip the second fraction, 2 over 1. Now I just got a multiplication problem. I can make this 4 over 1 if you really want to. 4 times 2 is 8 over 1. 1 times 1, which is the same as 8. All good so far? Hopefully. If you do have any questions, just jot them down. I'll try to answer them when you send me pictures of your notes later, or you can always email me and we can set up a time to meet also if you got a lot of questions. All right, I'm gonna get a new page. Let's do some more division problems. Now I wanna do 1/2 divided by 3/5. So drawing a picture for this would be hard because literally what this means is how many lengths of 3/5 can fit into 1/2. It's not going to be an obvious answer. You can't even, 3/5 is bigger than 1/2, so you won't even be able to fit a full 3/5 into it. But if we use our algebra rules, keep the first fraction, change division to multiplication, flip the second fraction, and now I just multiply across. Now I can tell there's nothing to reduce. 1 times 5 is 5. 2 times 3 is 6. My answer is 5/6. Literally, that means I can fit 5/6 of a length of 3/5 into 1/2. Kind of confusing. All right, one more like this, and then we'll get into addition and subtraction. 2/7 divided by 1/4. So how many 1/4 go into 2/7 is what we're asking. So keep the first one, change division to multiplying, flip the second one, and notice there's nothing that's going to reduce. So 2 times 4 is 8, 7 times 1 is 7, 8/7 is your answer. And you can leave it like that. It's the same as 1 and 1/7, a mixed number is a full 7 out of 7 plus 1 more. But you don't have to do that. And as we get into upper level math, like in college, you're going to leave them as improper fractions rather than mixed numbers. Okay. All right. So the last big step is adding and subtracting. And these are the ones that usually give people the most trouble because for one reason, it's not like multiplication and division. There's an extra step you have to do. And anyone remember what that extra step is? What does adding and subtracting need that multiplying and dividing doesn't with fractions? Common denominators, right? So first step is to determine a common denominator. Okay, we'll talk about what this is in a second with an example. After you do that, you're going to rewrite both fractions with that common denominator. Okay. Once you have common denominators, then you can just add across or subtract across. So add or subtract numerators. Keep the denominators the same. So you don't add those together. And with addition and subtraction, you could reduce early with, sorry, did I say addition and subtraction? With multiplying and dividing, you can reduce early. With addition and subtraction, you can only reduce at the end if possible. Okay, so let me give you some examples and we can work through this and see how that looks. So first example, if I've got 1/2 plus 2/3. So first off, this is absolutely not 3/5. Do not add across the top and add across the bottom. That's the first big mistake you want to go away from. You want to look at your two denominators, 2 and 3, and determine a common denominator. So what that is it's essentially the smallest number that both 2 and 3 divide into. So if you have trouble finding those ever, you could kind of list them out. You have 2, 4, 6, 8. All those numbers are divisible by 2. 3, 6, 9, 12. All those numbers are divisible by 3. You're looking for the lowest one that's in both lists. That's the least common denominator. That's the least number that's divisible by both 2 and 3. Okay, so the first step is to figure out that this has an LCD, least common denominator, of 6. So then what I do in my next step is I write 2 fractions with 6 on the bottom instead. And you can always change a fraction by multiplying it by 1. You know, any number in the world, if I multiply by 1, it doesn't change. 73 times 1 is 73. 128 times 1, 128. So if I multiply something by 1, it doesn't change it. But what do I need to multiply 2 by to make it into 6? 2 times 3 is 6. So if I multiply the bottom by 3, I have to multiply the top by 3 also. Because then I'm not really multiplying this whole fraction by 3. I'm multiplying it by 3 over 3, which is 1. So I'm not changing the value. 1 times 3 is 3. 2 times 3 is 6. So 3/6, you all can see that that's equivalent to 1/2. By the same token, 2/3, multiply top and bottom by 2. That's going to be 4/6. So that was step 2. I rewrote both fractions with that common denominator. Step 3 is where I'm going to add or subtract the numerators. So if I have 3/6 and 4/6, now I have 7/6. I keep the denominator the same. Final step is to reduce if possible, but there's nothing that goes into 7 and 6. Okay, so just as a side note, notice here I can't say that this becomes a 2 and this becomes a 3 because we can't reduce early when there's adding in the middle. So on this side, I was allowed to reduce early, but there is multiplication. When there's adding, you can only reduce at the last step. Now let's do another one. Let's do 2/15 minus 3/10. So if you were to list out all the multiples of 10, all the multiples of 15, what's the LCD? What's the lowest number that goes into both 15 and 10? It's going to be 30. So we're going to write 2 fractions, both with 30 on the bottom. Keep that minus sign in the middle. What do we have to do to 15 to get 30? Multiply by 2. 2 times 2 is 4. What do you have to do to 10 to get 30? Multiply by 3. 9. Okay, so I have 4/30 minus 9/30. Subtract across the top, it's 4 minus 9. Negative 5/30. Again, notice I didn't do any reducing early, but now I can reduce. Now there's one fraction. There's no subtraction or addition, so I can reduce. What goes into both 5 and 30? 5. So my final answer here is going to end up being negative 1/6. Okay, remember, if you've got any questions, please feel free to jot them down and ask me. All right, a couple more examples. I'm going to have you try a couple, and then we will be done. If I did 7/12 minus negative 4/12. First off, what's your LCD? Well, kind of a trick question. LCD is 12. They're already common denominators, so I don't have to worry about rewriting them. But when you have minus and negative, what do? Make it plus a positive. So this one's actually pretty easy because there's not that middle step of needing to rewrite it. Now I can just add across the top. That's 11 over 12. There's no reducing to do. That's it. All right, Last example I'm going to do, then I'm going to have you try a few of these. What if I did 17 thirds minus 5? What do you think the common denominator is? Well, yeah, remember this is really 5 over 1. So the least common denominator, if I count by 1s or count by 3s, it's going to be 3. So I'm going to write 2 fractions, both over 3. 17 thirds can stay exactly the same. What's going to happen to 5 thirds? Well, if we multiply the bottom by 3, I got to do the same to the top to keep it equivalent. So this is 15 thirds. And finally, when you subtract across, what's your final answer going to be? 2 thirds. And there you have it. Okay, so let's just make sure you understand this all. So I'm going to give you a few to try. We mixed up adding, subtracting, multiplying, dividing. And my directions are just going to say perform the indicated operation and express in simplest form. So in other words, that means reduce. And I've got 4. The first one is going to be 3/4 plus 1/8. Second one, let's do negative 1/4 minus negative 5/6. This one right here, I'm going to do negative 3/4 times 2/9. And the last one will be 2 thirds divided by 4/5. So what I'd like you to do at this point is to pause your video and take maybe 5 minutes or so, however long you need. Try these 4 problems. Once you've tried them, gotten an answer, press play on the video and see if they're right. So go ahead, press pause right now and give those a shot. Did you press pause? You should have. You didn't do it now, really, do it. If you have done it and you're ready to check the answers, here we go. So what I would like you to do is don't erase anything you did. I would love to see your original work. Normally I would walk around in class and see all of your work at this point while you were trying it. So what I would prefer you to do is if you made a mistake, maybe just put an X through your work and write my work off to the side so you can see where the mistake was made. Okay, anyways. First one is adding. So we need common denominators. What is the common denominator? 8. So you make 2 fractions, both over 8. This first one, what do we have to do to the 4? Multiply it by 2. Same with the 3. So it's going to be 6/8. Nothing happens to 1/8. And now I just add across the top. 6 plus 1 is 7 over 8. So 7/8 should have been your answer for that first one. Second one, it's subtraction. And right away, I would make this plus a positive. Anytime you're dealing with negative numbers, kind of do that. But we still need common denominators. So what is your least common denominator? It's actually 12. If you said 24, it'll work. You should get the same answer at the end. There's just more reducing you need to do. But if you notice that the LCD was 12, that was the best way to go. First one needs to get multiplied by, top and bottom, by 3. So it's negative 3/12. Second one, top and bottom, would get multiplied by 2. 5 times 2 is 10/12. Negative 3 plus 10, add across the top, we get 7. Keep the denominator the same, 7/12. Should have been the answer for B. Okay? For C, 2 ways you can do it. You can multiply across. Negative 3 times 2 is negative 6. Over 4 times 9 is 36. But remember, then you do have to reduce. So what goes into both of those? You can divide both by 6. So this would end up being -1/6. Now, since it was multiply, if you wanted to use that reduce early trick, that would have been fine too. There's a 2 on top and a 4 on the bottom. A 2 divides into both of those. So I can divide this by 2, leaving me with 1. Divide this by 2, leaving me with 2. 3 and 9 are both divisible by 3. And again, one's on top, one's on the bottom. You always need one of those to be on top, one of those to be on the bottom. So if I divide this by 3, I have -1. Divide this by 3, I have 3. And now if you multiply across with what's left, -1 times 1 is -6. 2 times 3 is +6. So if you reduce early, you just can skip that last reducing step. All right, last one. 2/3 divided by 4/5. Keep the first one, 2/3. Change division to multiplication. Flip the second one, 5/4. Multiply across or reduce early if you want, whichever you prefer. 2 times 5 is 10. 3 times 4 is 12. Since I didn't reduce early, I'd have to reduce now. I can divide both of these by 2. 10 divided by 2 is 5. 12 divided by 2 is 6. 5/6 is my answer. And if you did reduce early, because the 2 and the 4 could have both been divisible by 2, you can see how you get 5/6 right away. Okay? All right, so hopefully that was a quick refresher on how to deal with adding, subtracting, multiplying, and dividing fractions. There's no homework at this point on fractions. There will be one coming in the future. But one thing you can do, if you look at your Math 101 S Fundamental Ideas course pack, if you turn to page 2, or I guess it's page 1 technically, there's an intro paper. And you can start working on this. It's not due until Tuesday I wrote noon on here. I'm not sure if I intended it to be noon or 11:59. I'll get back to you on that. But anyway, it's not due until Tuesday. Basically, in a 1 to 2 page paper, double space, Times New Roman, size 12, 1-inch margins, write me a detailed response to the following. So I basically just need 2 paragraphs. First paragraph, answer all these questions. Where are you from? What do you hope to study at NAS? What are your interests? Paragraph 2, tell me how you feel about math. Tell me what math courses you've taken in the past. So what high school courses did you take? And tell me about how successful you were with those. Okay. Your paper must be emailed to me. That's my email address right there by noon on Tuesday. So how I'm grading this. First off, the content. I'm literally going to go through your paper and check off if you answered these 6 questions that I wrote here. So if you answered all the questions, then you answered all the questions thoroughly. Are you just rambling, or did you actually write things that are relevant? And did you organize it into the paragraphs like I asked you to? You get 5 points from that. The other 5 points come from grammar. So even though this is a math class, grammar's being able to write in all classes in college is important. So did you follow all the directions? And when I say all the directions, I'm talking about these right here. And you'd be surprised how often people lose points just for doing this. I want it double spaced. I want that to be the font, Times New Roman. I want it size 12, and I don't want margins bigger than 1 inch. And since you're sending them all electronically, I can check all of that. So make sure you follow all of that. Also, it says including paper length. So it says 1 to 2 page paper. That means 1 page means you got all the way down to the end of a page and spilled onto the second page. If you did that much, you met the paper length requirement. If it doesn't spill onto the second page, it's probably not a full page yet, so you're going to lose a point for paper length. So watch for that. Watch complete sentences, careful of spelling errors, watch your punctuation, word choices, all things like that. Okay? So you can start working on this if you want to get going on something. You can email it to me as soon as you're done if you'd like. But again, it's not due until Tuesday. This is a weird date now that I see on here. Sorry about that. It says 7/27. You pause for 1 second here so that I can figure out Okay. Sorry, there was just a mistake there. This should be Tuesday the 7th, not the 27th. Don't know where that came from. Tuesday the 7th by noon. Okay, so make sure you get that paper sent to me in time, and you should be all set. And I look forward to seeing you on a future Zoom meeting. Email me if you got questions, and good luck with the paper.